everybody, this is the second video on classifying matter. This video we're going to focus in on substances and mixtures, and we're going to touch a little upon the particulate theory of matter and how it pertains to substances and mixtures. You should, by the end of the video, be able to classify matter as substances, elements, compounds, or mixtures, homogeneous, heterogeneous. Okay, so let's get started. As you may have read, or as you hopefully have looked at my video, you should know that matter is anything that has mass and takes up space. And in the previous video, we separated matter into solids, liquids, and gases. But now, what if we take matter and we look at its the way that it looks, or some of those things, okay, some of those properties that it has. Okay, matter, it turns out, as this flowchart indicates, can be separated into two distinct parts. It can be separated into mixtures, and it can be separated into substances. So matter is either going to be a mixture or a substance. Okay. Now, mixtures are typically two or more substances mixed together. And so that's why this says here, separate physically, because you can take a mixture and you can separate a mixture physically into substances, break it down and put it into the substances that make it up. And then obviously underneath there are two different types of mixtures, heterogeneous and homogeneous, and there are two different types of substances, compounds and elements. So we're going to talk about each one of these and what makes them unique, and how we can classify them, classify these parts of matter. Okay, so like I said before, a mixture is just a physical combination of two or more substances, many substances. Okay, so a mixture is something like a salad. Okay, a salad. And I know there's all sorts of funny ways you can look at a salad, but a salad is tomato and lettuce and onion and olives and peppers or whatever. You can reach into the salad and physically separate those parts. Okay. In terms of the forces, a mixture can be separated by breaking the intermolecular force that holds the particles together. So let me show you or not show you. I think it's easy to visualize that a mixture is just many substances. Okay, when we start talking about physical and chemical changes, we'll talk about breaking intermolecular forces and breaking bonds. So a substance is a type of matter that cannot be physically separated into different parts. Okay, but it has unique properties. So one of the things that I assume that you guys know is that all matter is made up of protons, neutrons, and electrons. That is not a substance. Those are subatomic particles. Everything has those. Okay, so a substance is something that has unique properties of matter and cannot be physically broken down anymore. So something like water. Okay, water is a unique molecule and can't be physically separated. You can break the bonds that hold the H2O together, but that's a chemical reaction, not a physical reaction. Okay, so mixtures, things that can be separated physically. A substance has unique properties and cannot be physically separated. Okay, so there are two different types of mixtures. Heterogeneous mixtures means that things are not uniform. So again, something like a salad or a hamburger or a Reese's Pieces sundae. Okay, you can see the different parts of it. Okay, a homogeneous mixture is something that is uniform, it is consistent throughout the whole mixture. Okay, so something like salt water, okay, for the most part is a homogeneous mixture. Milk is we hope is a homogeneous mixture. It's made up of many different ingredients, but that first sip of milk on the top is the same as the last sip of milk at the bottom of the jug. So we have homogeneous mixtures that have the same consistency throughout. Okay. Sometimes we call these homogeneous mixtures solutions. In the case of salt water and milk and things like that, those are called solutions. Okay. Now, compounds and elements, realize that compounds cannot be broken apart physically. They can only be broken apart chemically. Okay. So, let's start with elements. Okay. Elements is the smallest fundamental unique part of matter. Okay. And so elements you can't break down into a smaller part that is unique. Of course you can break elements into protons, neutrons, and electrons, but one proton is not different than another proton. Okay, so elements are the smallest unique part of matter, okay, that can't be broken down any further. Now, how can you tell if something is an element? Well, that's what the periodic table is for. There's a list of 114 elements right on the periodic table. If it's not on there, it's not an element. Okay? Or maybe more appropriately, if it is on there, it is an element. So if you look on the periodic table and somebody said, what is sugar? Okay, you would look. There is no element sugar on the periodic table. There's only, it's just not there. So it must not be an element. Okay, it actually turns out to be a compound because that is two or more elements bonded together. They are chemically bonded together. It's a mixture. Sugar happens to be a mixture of carbon, hydrogen. Sugar happens to be a combination of carbon, hydrogen, and oxygen with all those elements bonded together. Okay. So, now that we have those definitions down, let's try to classify these. Take a minute, pause the video, and let's try to classify these as either a mixture and a substance, and if it's a mixture, if it's homogeneous or heterogeneous, and if it's a substance, if it's an element or a compound. Okay, so now that we've got the answers, let's see. Apple juice. Apple juice has typically many ingredients, or even just a couple of ingredients. But the fact that it has many things make that a mixture, because we can separate those components of the mixture. And because it's a mixture, well, now we have to figure out if it's a heterogeneous or homogeneous mixture. Well, the way I like to look at it is apple juice chunky? God, I hope not. Okay, so that first sip of apple juice is the same as the last sip of apple juice. So therefore, apple juice is a homogeneous mixture. Okay, the next one, gasoline. Gasoline, believe it or not, is a mixture. Okay, we know that it's a mixture because, or one of the supporting things that you should realize about gasoline is that you can go to the gas station and you can get 3 different varieties of gasoline. That implies that it's a mixture of different combinations of different things. And so again, we could separate those physically. Typically we would separate gasoline using something called distillation. We would heat something up, heat up the gasoline and let it turn into a vapor, cool the vapor, and we could separate the gasoline into its parts. And again, gasoline is not chunky, so because gasoline isn't chunky, since it's the same throughout the whole gas tank, we would call that a homogeneous mixture. Now, chlorine gas. We look at the periodic table, we will see that element number 17 is chlorine, and so that must be an element. Okay, and then lastly is salad. A million examples I've already talked about, but salad definitely has parts that you could see and physically separate, So that makes it a heterogeneous mixture. Okay, well, that concludes my video on the parts of matter. Have fun.